So for the introductions, I will explain about a pump in general and piston pump. So what is a pump? A pump is a mechanical device that uses mechanical action to move fluids and have hydraulic energy occurs in pump. So for the piston pump, it have just two valves and one stuffing box, and it use suction to raise water into the chamber, and the lower valve can be placed below water level. And then for the piston pump, it must be within 25 feet of the water level, so the water can be then raised. So now I will explain about reciprocating piston pump, the pump that my group has choose to explain. So the definitions of reciprocating piston pump is a positive displacement type of pump that operates on the axis of the piston, moving forward and backward. When a specific amount of fluid needs to be moved from the lowest area to the highest area using the pressure, reciprocating pumps are utilized. So how does this pump work? So I have put some example diagram in this video so everyone can see it. It works. How does it work? It works from the suction stroke of a reciprocating piston pump draws fluid, and while the compression stroke, it compresses and expels the fluid. This constant reciprocating motion creates a steady and dependable fluid flow, which qualifies the pump for applications that need accuracy and consistency. So now I will explain about operational principle of the pump. So reciprocating pumps operate on the principle of a positive displacement, which means that regardless of the discharge pressure, they move a certain volume of each stroke. And reciprocating pumps also use the back and forth action, as you can see in the slide, of a piston or plunger to transform mechanical energy into fluid. For the basic principle of reciprocating piston pumps, there are 6 of them. So the first one is the piston expels liquid through a one-way valve, and then the second one, the pumping rate is adjusted by controlling the distance of the piston retracts and limiting amount of liquid that is pushed out by each stroke. The third one is CAM, pushing a sapphire piston back and forth. So the fourth one is when piston moving backwards, it sucks the effluent through inlet check valve, and the sapphire ball is lifted, allowing the effluent to pass through. When the piston moves forward, it causing the liquid to push the inlet ball down, closing the part. Meanwhile, the outlet ball is lifted and opening the outlet valve.
Okay, so let's continue with the components of recuperating piston pump. Recuperating piston pump consists of 8 important components, which are piston rod, piston, connecting rod, cylinder, delivery valves, delivery pipe, suction valve, and suction pipe. So the first one is the piston rod. What is piston rod? Piston rod is connected to the piston, transmits this motion to the crankshaft, converting linear motion into rotational motion. So, what is piston? Piston is the part that creates suction and pressure by recuperating inside the cylinder. What is cylinder? Cylinder is the chamber where the piston moves back and forth, and the function of connecting rod is the rod that connects the piston rod to the crank. Moving on to the next component, which is a delivery pipe. What is delivery pipe? Delivery pipe is a pipe that connects the cylinder to the fluid destination. And the delivery valve is a valve that allows the fluid to exit the cylinder from the delivery pipe. However, suction pipe is a pipe that connects the fluid source to the cylinder. And lastly, the suction valve is a valve that allows the fluid to enter the cylinder from the suction pipe during the suction stroke.
So I'm gonna explain about the applications of this pump in industry. First, we have hydraulic system, where it plays a crucial role in hydraulic machinery and provides necessary pressure to operate different components. Next, we have oil and gas industry to transfer liquids during the processing. We also have automotive industry where it can be used in hydraulic brakes, a hydraulic brake system where precise pressure control is very essential. Lastly, it is also used for high pressure cleaning as it is effective for cleaning applications such as to remove dirt and germs. Let's move on to the next one. So here, as you can see, I have listed some disadvantages and advantages of this pump. The first one of the advantages is high pressure generation. It can achieve very high pressures, making it ideal for demanding applications. Next, it is proven technology. The design is well established and reliable, with years of successful application in industries. Moving on to the next one is durable. It is robust and designed to last even in harsh operating conditions. Moreover, it is also has high suction lift. It can draw fluids from deep levels, useful for situations requiring significant lift. And then, it is wide pressure range. It operates effectively across a broad range of pressures, ensuring its versatility. The last one is constant rate of discharge, where it provides a steady and consistent fluid flow regardless of pressure changes. As for the disadvantages, let's start with high maintenance. It requires frequent servicing due to wear and tear of moving parts. Next is pulsations, where uneven flow might be produced that will cause pressure fluctuations in the system. The next one is potential self-damage. The risk of getting damaged if operated improperly or under adverse conditions is high. Moreover, we have low flow rate, where it delivers a relatively smaller volume of fluid compared to other pump types. It is also bulky and heavy as its design and construction make it large and difficult to transport. The last one is space requirement, where it needs significant installation space due to its size and configuration. That's all for disadvantages and advantages that I have stated.